I'd like to welcome on stage Chris Paruch from the Cryptoeconomics lab in Vienna. And you might have already heard, he not only is giving a talk about token engineering and this new emergent scientific field, he also curated the scientific track, and he's, let's say, contributing to this sector and bringing together research to this practitioners area in a super valuable way. Welcome, Chris. Give him a round of applause.
Thank you very much. Thank you, Angela. Hi. Hi, good afternoon. Hi, I'm Chris. I'm from Vienna, from the Research Institute of Economics, and I started to engage there around 1 year ago, shortly after I visited and took also had a keynote at the last year's Token Engineering Global Gathering here in Berlin. And what I'm doing is I'm trying to synthesize the methods from mathematics, from engineering to economics, because as my previous speakers already discussed today, we need to get a more rigorous approach in designing these ecosystems. And I want to talk today about the ecosystem and the purpose-driven ecosystem, because for those of you who have attended today in the morning, Shermin, the director of the institute, she was introducing the concept of purpose-driven token. But the token is only on the bottom layer of the ecosystem. And I try to describe how this token and the purpose of the system can connect. But let's start with a short motivation. Unfortunately, I'm not allowed to show a video here, so this is why I took some screenshots. And if you look at YouTube, you can find this. But what I wanted to show is a self-driving motorcycle. And it's a funny video, you should check it out. And what you can see there is that this is a machine that is autonomous and that is pursuing a goal as a system. And the goal is to stay upright all the time, even without a driver. And it's pretty funny because on the video you can see that the guys try to tackle the motorcycle and they try to even kick it in order to stop it, but it always gets up again. So I really recommend to check it out, because what you can see here is a system that has a purpose. The purpose is to stay upright and stay running all the time. But this system is a complex system, and it's an automated system. So what does it mean? It means that in robotics, we have very rigorous methods and very rigorous models of designing these kind of automations. So why don't we do this also in economics? And those of you who have attended today's talk in the morning as well might remember this slide. This slide describes the history of economic schools. And it's not everything, so you can see two of them. So this is from top to bottom. What I'm trying to say here is that economics is a scientific discipline that describes social interactions within communities. And we started to analyze this around 250 years ago. But at quite some point in time, we decided to go into a direction where we used simplified methods, because it was very difficult to observe and calculate what is going on in the economy. But it was very easy to do so in robotics and in automation. So my suggestion now is, why don't we use these tools that we have from complex system engineering and try to synthesize them into economic design? So let's talk about some core concepts maybe. What are complex systems? A complex system is a system that consists of more than one subsystems. So you have different parts that are connected to each other, that affect each other, and that they also influence. What happens in one will have a huge interdependency with the results of what happens in another one. Think of the motorcycle, right? You also have different components that inform and influence each other, and they always take into consideration what they can observe in another subsystem in order to understand how this might influence their state and their decisions. And I try to argue that economics is a complex system as well. So what are dynamic systems? A dynamic system is a system where time plays a role. So you simply cannot take a snapshot of economics, of the economy today, and try to understand, try to model, or try to design it in the future. So we also should take this into consideration. Let's talk a little bit about different scales and different perspectives. The most economic schools, or the most understanding of economics, says that we have a micro perspective, the individual level, and we have the macro perspective, the aggregate level of the economy. So these are two different scales. You can look at what's going on in the bottom, or you can look at the economy as a whole. In modeling automated systems, like for example this motorcycle, this wouldn't be enough. So you need more than one of these layers to understand what's going on. And what you also need to do is to connect those layers. And this is called micro foundations and macro contextualization, which means that in order to understand what's going on here, you need to know what's going on here, and so on and so on. So for each of these layers, you can make pairs, micro-macro pairs, and say that you need, for the top-down approach, you need the aggregate relationships to be consistent with the fundamentals, and from the bottom-up approach, you need to put the principles that you derive into the context of what's going on above. Another very important thing when modeling is taking into consideration different perspectives. When we look at decentralized digital ecosystems, we would be looking at the economic side, we would be looking at the technical side, legal side, and so on and so on. We need to understand this in order to have a good understanding of how the system as a whole might evolve over time. So now let's define what is purpose-driven. And I would like to talk about attraction here and not about incentivizing, because this is the core difference. What we want to achieve with our ecosystem, with our design of the economy, is we want to set a goal of the economy and to try to draw the people to this direction and not the other way around. Because when trying to push people, you might get them to another outcome that you imagined. But if you define some sense of a gravity of the system, the purpose, the goal, and if you derive all the mechanics and dynamics of the system in consistency with that, then you will really design an economy that has a specific purpose that you want to design. Another important aspect is dynamic control. Michael Zarkam was talking about this today with complicated words, I know. But what he was trying to say is that we have to control the system over and over again. Imagine that you want to fly to the moon. You can define some controls. You can define which direction you want to go, which height you want to go, which speed you want to go. But you have to allow yourself to change these controls over and over time, because you don't know how the environment will react. So this is why in designing and controlling and governing these ecosystems, we need to apply this dynamic control. So now let's try to connect how these concepts from system engineering might be consistent with economics. When we observe the world that we want to model or that we want to design or that we live in, we are facing a lot of data, a lot of information that we cannot really compute, we cannot understand them. So most of our models or most of our approaches trying to design, steer, and control these economies rely on very limited data. So we only try to use the tip of the iceberg. What we do as well is simplification. So the methods and the models that we use are heavily simplified because it's easier to understand, it's easier to derive policies from them, and it's easier to compute. But now, since we are engaging in building digital economies, we can solve these issues, right? So what we have is computational power today, and the reason why we can apply the systems engineering approach into ecosystem design is because we can rely on computation, and we can rely on data. Digital economies that are purpose-driven inform us all the time, continuously, about the state they are in and about the interactions that are happening. So why don't use this, similar to the automated motorcycle, to design an economy with a purpose? So what is token engineering then? Token engineering is the design of purpose-driven systems. And I would even go one step further and say that it is the design of cyber-physical economies. What does it mean? We live in an economy every day. A part of this economy we can tokenize. Here, we would apply token economics. If we want to design and control these token economies, we would use the methods from token engineering in order to build a token that would then again connect these two words. So it is therefore cyber-physical, because you can with the token not only control the digital economy, but also the effects that it has on the real world. So this is why token engineering is the cyber-physical economies design. What then is the job of a token engineer? Very simple. It is to model, it is to simulate, and it is to tune over and over again. So first you need to discover what you want to build, then you have to design mathematical models, you have to design simulations for it, and then you can start building. It's a task similar to a system architect, right? So if you were to build a building, you would first make a plan, then you would maybe simulate how will this building or the bridge develop over time under environmental influences, and then you would adapt the way you build it. So maybe now let's talk a little bit about economic controls. Since we can maybe compare real-world economics to digital economics, I would like to use this example to understand or to show you how controls are applied in real-world economics today. What we have is, let's say, some kind of a market where the social interaction takes place. And we as humans, as social beings, we elect a government in order to drive us towards some goals that we want to achieve as a society. You can think of a nation state, right? You can say you live in Germany here, and you elect representatives that try to steer the country into a specific direction in order to achieve goals that you set for this economy. And typical goals are, you would say here, for example, price stability within the economy, and you would say the growth of the economy. But what you need to understand as well in economics, and this is why we have so many political issues, is that the goals that we want to achieve sometimes contradict, and we have trade-offs between them. So you cannot simply apply controls, or you cannot simply design the system and let it evolve in this envisaged state, because this will not happen. So what you need to do is you need to maybe separate policies and say, okay, we can apply this policy to reach this goal, and we can apply this policy to reach this goal. What I'm talking here about in particular is, for example, you can make the separation of monetary policy and fiscal policy. So in many economies you use monetary policy to achieve price stability, and you use fiscal policy to achieve growth. But the problem we have as well with the market is that we have market inefficiencies and we have shocks from the inside of the economy, but also from the outside. But still, the controls, the policies that we apply are within the system. So what I'm saying here is that the system has to react to shocks from the inside and shocks from the outside. Think of the motorcycle again. This motorcycle didn't even fall when people were kicking it from the outside, right? It managed to stay upright. Because the policies that the parts of the motorcycle applied were steering this system towards the goal of staying upright all the time. So, how do we want to model it? We need to at least apply 3 scales in our multiscale modeling. We need to model the economic system as a part of the outside economy. So we need to say, okay, how does this economy that we build connect to the outside world? For example, if you design a cryptographic ecosystem, blockchain ecosystem, you can say, okay, how does it interact with other ecosystems, or how does it interact with the real world? You need to understand this. Then you need to make subsystems and understand how this system might be separated into subsystems that inform and influence each other. And for each of those, you would then make this loop. You would say, okay, which action would lead over which mechanism to which state, and how do you value this state within each of these subsystems? And what you need to remember is that you need to make micro foundations from the top to the bottom, and macro contextualizations from the bottom to the top. So now let me talk a little bit about this last part here. How does it look in particular? This is again systems engineering, and we want to apply this on economics. So we want to separate our system into subsystems. These would be the lanes. And we want to understand how different actions that we take here over which state update functions would lead to which states, and then we could apply KPIs, health metrics on it. So we can say for every step, we could say what happens here leads to this, how we value this. And this would again inform the agents or the controls here. The diamonds are, for example, you can say human behavior. So you can say, okay, these are agents, people who are interacting with the ecosystem. Here, this would be controls that you can apply. And these would be random processes. You still need to include them, right? And again, you see that, for example, the controls are only a part within the economy that try to steer it. So how does it look as a whole picture? We are the humans, right? We want to define the goals of our ecosystem, and we want to design, implement, and govern here the software or the mechanisms that can make the ecosystem grow or make it alive. And according to these goals, we would need to define all of this, which is basically here. So how would this logic apply on our ecosystem? Which actions lead to which state changes and which evaluations again? Then we could build the model of this, and we could start simulating it. And if we do so, we will then be informed again and can define new goals or design new changes to the implementation. So this is what we try to synthesize. Complex systems engineering, think of automated motorcycles, and they are decentralized because they do not have a driver, right? You do not need someone to control the system, and it still stays upright. And we want to bring this into economics. Thank you.
Thank you so much, Chris. Maybe I haven't mentioned yet that we are happy if you share the talks and the comments to the talk on Twitter and hashtag. I think, Chris, this was a super good introduction to the token engineering area. Thank you so much, which is also approachable, I think, for many disciplines and people from many different backgrounds. So thank you very much. And here's our present. And see you soon. Maybe at the hangout session tonight, networking in drinks. And feel free to approach and connect with Chris. Again, tech.io/program, and you'll find his Twitter account, and feel free to connect to him.